So I will take you through an example of building a machine learning pipeline inside a database, but before I go there, I just want to talk a little bit about myself so you know who I am, right? And so just put some picture around myself, right? So I've been with IBM more than 17 years. So as a software developer, and last 6 years I have been as a machine learning architect within IBM. So I filed 10 patents applications so far, and I have been I have collaborated with research partners from different universities, and so far published 12 scientific publications. And I'm also doing a PhD in machine learning. So I'm a student. So I'm a part of the student and academia community that you all, I mean, most of you belong to. Let's get to the topic. Here is a workflow of developing and deploying a machine learning pipeline in the business, right? So we can divide this into two phases. The first phase is the research phase. In that phase, we bring some sample of data with which we run some experiments. So our goal is to find the subset of the features best perform that give us a more accurate model. We also search for algorithms. So there are many different choices. If it's a supervised machine learning model that we want to build, that means we'll be looking for maybe we'll explore with logistic regression, different boosting trees such as XGBoost, sometimes also deep learning techniques, right? And so we want to find the best combination of features, the best learning algorithm. So with that, we come up with a pipeline. So with that pipeline, now we also train a model using a data set, right? And this training part is not a one-time thing. As we know that machine learning is a continuous process. As the data changes, we also need to retrain a model with the new data, right? So there is a continuous aspect, so we need to retrain the model. So once the model is trained, we also need to find a place for deploying this model, because just creation of the model is not sufficient. We need to make this model available for business users and to make use of it. So we also need a solution for deploying it. And finally, once the model has been deployed, the model and the predictions from the model need to be integrated with the business applications. So as you can see, the whole process could be quite complex, and there are multiple personas involved in the development of a machine learning model. So we have business SMEs who understand the data. We have a data scientist or ML engineers who are coming up with the best performing pipeline. There is a ML ops engineer who is taking this pipeline, deploying it somewhere. And then we have BI/application developer who is bringing those predictions to the business user. So there are different personas, there are multiple process, and then typically often in the enterprise setup, the machine learning data comes from relational database management system. I think a couple of years ago, I checked out in some Kaggle surveys, and then I kind of estimated that from the survey numbers that roughly 60% or more the machine learning data sets in enterprise comes from relational systems. Such as IBM Db2, and there are other relational database management systems available there, but those are that's the source. So as you can see, predominantly it's coming from relational sources. The model development often happens externally to the database. People or data scientists take the data, copy this data to some other places, could be open source solution or maybe commercial proprietary IDEs. And then once the model has been developed, it's deployed somewhere, and then it's also need to be integrated. The integration can be challenging. Typically, many ML prediction services provide API interface, such as a REST endpoint for model integration. So you have your data sitting in one place, and then your model is sitting in another model registry. Then you are kind of as a developer, you're writing code to bring data from the database and then you are preparing a REST API and sending that request to the model, the prediction service, you get the predictions back. So there could be some complexity in implementing this kind of workflow, but it can be fine for many use cases, especially the companies who have matured machine learning infrastructure and system. However, it can be challenging with the ML projects that are just getting started, and then maybe they're not up for making a lot of investment. So what we are proposing at IBM Db2, a built-in infrastructure for model development, model deployment, and model using, right? Everything inside the database. So you have data, machine learning data set stored in IBM Db2, and now we also provide over 200 stored procedures that can help you build an end-to-end machine learning pipeline in the database. So the data never leaves the boundary of the database, and which can be a practical solution to sensitive data. As you know, there are very strict regulations that prevent you, or that makes it very difficult or challenging for you to copy data outside of the database, such as GDPR, CCPA, things like that. And so there is a very strict regulation. So for those kind of situations, right, if you can do in database machine learning, and also since this infrastructure or ML infrastructure is built in the Db2 system, which means you could leverage the IT resources that your company has already invested, right? So you don't need any separate infrastructure for model development, model training, model serving. Everything is part of this. The other aspect is this. The language for using the model that is created and deployed in the Db2 is SQL. As we know that the SQL has been around for a long time. So pretty much virtually any application already that gets data from Db2 or any relational database management system already has can talk to a database, right, via SQL. So now we're making this these predictions available via SQL query. So all you need to do to get predictions from ML model that is in Db2, just write a SQL query, and then you get the predictions. It makes the integration much simpler. You don't have to go to external model registry for getting the predictions. Yeah, so we also have additional capabilities for integrating externally trained ML model with Db2, such as you can build machine learning model using open source ecosystem, such as scikit-learn, XGBoost, TensorFlow, things like that. Or even you can build model with RStudio. So we have Python UDF, user-defined function. We have RUDF that allow you to bring externally trained model back to Db2. So you could build model with IDs such as Watson Studio, Auto AI, and you can bring that model, trained model, back to Db2 and for inferencing. But today I'm going to primarily focus on the machine learning capabilities that are natively available in Db2. The open source aspect I'm not going to talk about, but there will be links, so you can also look into those for more information. Okay, so let's get into the demo. So for this demo, I will show you building a linear regression model using Db2's native capabilities. So I'll use a data set called a Go sales data set. It's the historical or actually synthetic data of customers from a store. So the customer, many customers, they have visited a store and made different purchases. So they spend some money, right? So so we have those data. These are synthetic customer data. For each customer, we have certain features such as the gender of this customer, each customer's gender, their age, marital status, profession, and also how much they spend. So, so we want to learn a regression function that will learn a set of coefficients for one per input feature, in this case xy, x2, x3, x4, and then also intercept, and then we want to learn these coefficients and intercept values from historical training examples, and then so that when we have a new customer data whose purchase amount we don't know, we can use this function, this learn function, to predict the purchase amount. So I will build this pipeline in DB2. I'll take these steps. Train test split. So I have historical training data of customers. So I'll divide this into train and test partitions. I'll do data exploration, data pre-processing, model training, model evaluation, model management. I'll show you how each of these tasks can be accomplished in DB2's in database machine learning stored procedures. So I'm going to switch to another view where I'll show you this in action. Just okay, so everything that hopefully you can see my screen again. Ganeshan, please confirm.
Oh yes.
Yes, we can see.
Yes.
Okay, so everything that I'll be doing are is via SQL statements. So first of all, so I'm using a database client called dbeaver. It's open source, but you could use any other database clients, or even you can just go to DB2 command line prompt for doing this. Okay, I'm just using a client so that I can also show you the results visually. So the very first thing I want to do is I want to take a sample rows from this table called go cells _ full. Okay, so let me take a look. Okay, so as I can see some sample records, I just fetched 5 records. There's ID column, gender column, age, marital status, profession, and purchase amount. So I can see different values that are present in each of these columns. Of course, we ignore the ID column because that's not a feature column. The gender, the male, female, the age values, married, profession. Okay. Next thing is I'm going to do is just counting how many records are there. So there are a little over 60,000 records. So next, I'm going to use a stored procedure from DB2 called split _ data. So this is split _ data stored procedure takes some certain parameters. So there is in table parameter where I'm giving the name of this table, which has the complete data set. I'm also giving a name of the training table. This table does not exist yet, but this stored procedure will partition this original data set and then put the training partition in this table, which this stored procedure will call. The training partition table will be called go cells _ train, and also it's going to put the remaining records into a test table, which again this stored procedure will call, and the name of this test table will be go cells _ test. I'm also mentioning the fraction of this for these partitions, right? I'm saying that 80% or 0.8, so 80% of the records would go to training table and the remaining 20% would go to test table. So let's run this. As I'm running this, you will see that the tables that are available in this schema. Excuse me. So right now we only have 2 tables goes in this schema, go cells schema, go cells _ data set, go cells _ full. This data set is another table which you can ignore, but let's run this one now. This split data stored procedure. Okay, so it actually completed. So 80% of the records went to this training table. so which roughly 48,000 records, and the remaining one went to test table. So now let's refresh this. Yeah, so now we can see two new tables. So I'm going to just count how many records are in each table. One count we have seen anyway, but I'll run this SQL. So it's a 48,000, a little over 48,000 in the training partition. And the remaining one about 12,000 records going to the test partition. Next, what we'll do, we have a stored procedure in DB2 called summary 1000. Okay, so in this stored procedure, it can collect data science summary statistics from input table. So the summary statistics it will collect and show you is very comparable to the data science kind of statistics, such as if you're familiar with Python ecosystem, and there is a package called Pandas. Pandas has a very popular function called describe, right? So you would get similar statistics. I'll show you very quickly, but let me take you through the input that I'm passing to this stored procedure. So of course, input table is the name of the table from which I want to collect some statistics. Out table where the statistics will be stored. So this is the primary table where statistics will be stored, but it will also generate some additional tables for each column type, like statistics from numerical columns will be stored in one table, and statistics from the categorical or nominal columns will be stored in another table. I'll show you that very quickly. In column, what are the columns, input columns on which I want to collect the statistics? So I specified this as a list separated by semicolon. Now let me run it. Okay, so it's completed running, and it has generated a bunch of tables. So there are three tables that are generated. The first one is the primary table, summary 1000. It's a table based on the name I have given. Also, there are two additional tables, car, which has a summary of the subset of the columns that are character type, right, or categorical or nominal column, whichever you want to call it. Then there are another table which has the summary of the numerical columns. So I'm going to show you the data from the numerical column first. It's make it easy that it also, this stored procedure put the summary for each column type in separate tables, because as you know that certain summary statistics do not apply to all column types. So maybe there are numerical columns, you can compute the average for that column, but the average does not apply to categorical column. So that's why it just make easier if to keep them separate. So first I'm going to take a look into the summary from the numerical columns. So from here, I see there is only one numerical column is, and so from here, I can see that the average value is 34, and there are other statistics. So I'm not going to go over. I'll just call out a couple of them. Minimum value 17, maximum value 69. Missing values. A missing value shows that there are 1,875 records which have missing values, and this is problematic because linear regression algorithm, it requires that we take care of the missing values. So we'll have to do something with the missing values later as we go to the data preprocessing step. Now let's take a look into the categorical column stat. So we have three columns that are categorical or nominal. I'm just using this interchangeably, categorical and nominal. So it shows the distinct values of what are the different unique values for each column type or each column. Then we also see that there are some missing values in each of these columns, which you'll need to take care of. So next stored procedure I'm going to use called impute_data. So what it does, it will it supports filling in any missing values in a input column with some replacement values. So these stored procedures support couple of I mean pretty much all the popular strategies for filling in missing values. It supports mean replacement, median replacement, or you can also specify or you can use most frequent value for replacing missing values, or you could specify a constant value for replacement. So I'm just for the numerical column is I'm going to use mean replacement, so which means whichever records have missing values, I'm just going to replace them with mean. Okay, so yeah, so now this stored procedures has filled in missing values in this column, which I'll confirm by running this query. So I'm just going to count how many records are there where S is null. So 0, so it has been taken care of. So similarly, likewise, I will replace the missing values in the nominal columns like gender, marital status, and profession using the most frequent value, and which I actually found from this character car table, which I generated using summary 1000 stored procedure. So I'm just going to run them quickly. Running one at a time. And after that, I will run count for each of this nominal column just to make sure that there are no missing values. 0 missing value. 0 missing value. Okay, so so now data is prepared, so we can train a machine learning model. But before going there, just want to see that what are the existing models. Yeah. Yeah, so I have two models, flight and go cells, but this go cells model will be replaced with a new model that I'll be training right now. So now let me train it. So the linear regression model for training in the database, I'm going to use this stored procedure, linear regression. Actually, I'm going to drop this model and recreate this. Let's see if I can find. No, that's fine. I'll keep it as is. It will be replaced. So this stored procedure model, so you give a name to this model that you want to create, and you provide the input table name, go cells _ train, that has the clean version of our training data set. Also need to mention the ID column name. Target, we specify, since this is a supervised machine learning model we are creating, we also need to have a target column. So it's saying that the purchase amount is the target, and we specify the list of feature in the in column. And also we are setting the value for intercept to be true, because we want to learn the value of intercept for a linear regression function. So now let's run this one. Okay, so I think I need to drop this one really quick. Just bear with me, please. Okay, so I'm going to drop this model because I ran this notebook. Sorry, I ran this before. That's why it's complaining that the model exists. But it's good that you also get to see the drop command. Okay, so I have dropped this model. Now let me just list some existing models. Okay, so I don't have that model anymore, so it should not complain anymore. Okay, good. Now I can list the models. So the model has been trained. Then the model that is trained in DB2 is a stored procedure. Those models are transparent. You can actually examine the coefficients and the values that the learning algorithm has learned. So in this case, the learned parameters from the training data set are stored in a model table called GoCells_linearreg_model. This name is just based on the name I have given. So as you can see, I gave this model a name, GoCells_linearreg, and then I just know that it will be in the model suffix, right? So let's see. One more thing I forget to mention. If you have a categorical feature or nominal feature for linear regression or many machine learning algorithms, you also need to encode them into some numbers. So there are different encoding schemes such as one-hot encoding. So in DB2, the inbuilt machine learning algorithms we actually do not require you to explicitly encode non-numerical or categorical columns into numerical ones. DB2 internally handles it. So in this case, we passed those list of categorical columns as is, and those were actually converted into additional feature columns using one-hot encoding scheme. For the interest of the time, I'm assuming that you're already familiar with one-hot encoding, but basically you can see that for each value in the marital status column, single unspecified married, this has become now a feature column, right? And then coefficient values are learned, and also the intercept value is also learned. So so all these values are available to me for take a look. Next one, I'm going to so you know that I also had a test partition. So I also need to take care of missing values in the test partition or the test table. I'll do it quickly. Right. So I'm imputing missing values in the S column, same in the gender column, marital status column, profession column. Now I will generate predictions for the records in the test partition. So for which I am using this stored procedure, predict linear regression, where I mention what is the name of the model that I want to use for generating predictions, and then what is the name of the test table, which has the input records for generating predictions, out table, where do I want to store the computed predictions from the model, right, for this test data set. So I'm going to run this stored procedure. Is here. Now I can just take a look that what the predictions are. So these purchase amount, these are actually predicted purchase amount, not the actual one. Now, since this is a test data set, we also know the actual. So now I will compute some evaluation metrics using DB2's built-in stored procedure. First of all, mean squared error. We have a stored procedure where we can give the result table and the original test original value for the purchase column, and then it will compute the mean squared error. We also provide mean absolute error, computed to be 10. And I also wrote a SQL query for computing mean absolute percent error, which is another metric for evaluating the quality of regression predictions from a regression model. So it shows that the errors are roughly about 8%, right, range. Finally, I think I'm almost done. Ganeshan, can I take 1, 2 or 3 more minutes? Then I'll.
Yeah, sure. Sure.
Sure. So as I mentioned, we have many stored procedures, over 200. Then using them, we can train a variety of models such as decision tree, naive Bayes, k-means clustering, association rule. There are more on our warehouse. I'm just showing you the subset of them. Linear regression you have already seen. So in terms of the benefit, so we provide a built-in ML infrastructure for model development, model training, model serving. So you don't need to copy data externally, as I already mentioned. Data protection, because data does not leave the database for this style of model development and model deployment. So your data remains protected. Eliminate data transfer, which is already obvious. Distributed processing, if your data is in multiple partitions, so some of our algorithm actually can parallelize the learning task and also inferencing task. Real-time inferencing, data and the model, they are co-located, so that cuts down the network overhead of data transfer. And then automated model deployment, as you have seen that once I trained the model was actually automatically created and deployed in a table. So I did not have to do any additional step for model deployment. That actually takes a big task out of the data science workflow. Simple SQL API, I already discussed about that. You just write a SQL query to get the predictions. It's super easy for getting predictions from the ML model to your application. So I'll share this deck with you. I have listed the demos and hands-on tutorial and Db2 documentation for more information about Db2's built-in stored procedure. And the final thing is you can connect me with via LinkedIn. I also blog frequently on Medium and also LinkedIn on ML topics and other topics. Finally, just as a token of appreciating that you have been with me, I just want to share with you, because I mentioned I'm a student, a PhD student, and I belong to your academic community. So one thing I just want to share with you that when I began my PhD, I really struggled with understanding or reading research papers, right? You know that as part of this research, and we all need to read a lot of papers, right? So I kind of learned to ask 5 questions that really help me when I'm to get the gist of a research paper. So just wanted to share with you. I try to ask what is the context of this paper, what's the problem it's trying to solve, what's the solution it is proposing, how did this research paper validate the solution and benefit. Just in case anyone is find this useful, I thought I'll bring this up, but it probably is obvious and you all are familiar with this. I did not invent this wisdom. I just learned from expert researchers, and I just organized and created this visual in case anyone finds this helpful. If there are any questions or anything, I'm happy to answer offline or online, whatever Ganesh you think is the best.